Hey guys, welcome back. Today we are doing 6.3 binomial radical expressions. Okay, so we're going to be adding, subtracting, and then multiplying radical expressions. Okay, so first adding and subtracting, super easy. Think about this as combining like terms, okay? So whenever you add, subtract like terms, it says to use the distributive property. All you need to think about is if they have like terms or like radicals and like indexes, then you can combine the numbers out front, adding or subtracting whatever operation is there. Okay, so for example, here's some examples that we're going to talk about. So like radicals with numbers, so like here we have the square root of 2 plus 3 times the square root of 2. Okay, in front of the square root of 2, there's an invisible 1. So since the root 2's are the same, all we do is add 1 plus 3. So it's 4 square roots of 2. Same thing, like if this was x plus 3x, it would be 4x. So kind of think about that as like your like term. Okay, here we have the index is 3, so 3 root 7 minus 5, 3 root 7. Okay, invisible 1 here. Since the 3 root 7 and the 3 root 7 are the same, we just take our numbers out front, the 1 minus 5, negative 4. Okay, and then we keep the 3 root 7. Same as if we have 5xy, as long as it's everything under the radical and the index is the same, you can combine. Okay, so here we have a 1, these are the same, 1 plus 8 is 9. Here, 3 root, then 9x squared y, 3 root 9x squared y, those are the same. So 1 minus 8 is negative 7. Okay, super easy. So let's do some examples. Nope, that didn't work. Okay, we're just gonna, because you know my smart board, it's acting crazy. Okay. So what is the simplified form of each expression? So we have 3 root 5x minus 2 root 5x. Check. Make sure the index is the same, so just root 5x, they're good. So all we do is say 3 minus 2 is 1. Okay? And so that's the same thing as, there's an invisible 1 here. All you would put is that root 5x. Okay, here we have 6x squared root 7 plus 4x root 5. Okay, we cannot combine these. These are not like terms. Root 7 and root 5, totally different. X and y, totally different, okay? So that's as simplified as I can get. Here we have 12, 3 root 7xy minus 8, 5 root 7xy. Okay, the 7xy is the same, but the indexes are different. This is a root 3, and this is a root 5. So those cannot combine, okay? So here we have 3 and then square root of xy plus 4x square root of xy, okay? Check, square root of xy, square root of xy. We're good, so all we do is add 3x plus 4x, which is 7x square root of xy. Cool? Here, check, 5 root 3x squared, 5 root 3x squared. We're good, so we just combine. 17 minus 15 is 2, so that is 2, and then 5 root 3x squared. Minus my smart board being crazy. Okay, here we have root 12 plus root 75 minus root 3. Okay, so those are not obviously the same under the radicals. However, they can be simplified. So the square root of 12, we need to make sure that we can, simplify these radical numbers. I'm going to come over here in black. So the square root of 12, we have to think, what's a perfect square that multiplies to get 12? Okay, well that's 4. So the square root of 12 would be 4 times 3, right? So that's the square root of 4 times, the square root of 3. The square root of 4 is 2. So we can take that square root of 4, which is 2, and bring it out. So this simplifies to be 2 square roots of 3. Okay, so I'm going to replace this root 12 by 2 square roots of 3, okay? If you struggle with simplifying radicals or, seeing what a perfect square is or anything like that, talk to me or Mr. Thomas and we can do some more examples to figure out, how to do that, okay? So, square root of 75, okay? I always think of, 75 as 3/4, okay? So, 3 times 25 cents or, 25 times 3, right? Well, 25 is a perfect square. Square root of 25 is 5, so we pull that out front, so 5 square roots of what's left over is that 3. Okay, so plus 5 root 3 minus root 3. Okay, well look now, we have root 3, root 3, root 3. So we combine our numbers out front. 2 plus 5 is 7, minus 1 is 6. So this is 6 root 3. Cool. Okay. Now multiplying. So with this, you're going to be multiplying a binomial times a binomial, and you have radicals in there. Okay, we know how to do that. It's distributive property or foiling, however you like to think about it. So first, we take 4 times 5. Okay, 4 times 4 root 2. Now we do 2 root 2 times 5, and then 2 root 2 times 4 root 2. Okay, so 4 times 5 is 20. 4 times 4 root 2, so 4 times 4 square roots of 2. We multiply our numbers out front, so 4 times 4 is 16, and then we keep our root 2. Okay, kind of, again, think of that root 2 as like a variable, what you would do then, okay? So this is 16 root 2, okay? 2 root 2 times 5, we multiply our 2 and our 5 to get 10 root 2, okay? And then here, let's look at this 2 square roots of 2 times 4 square roots of 2. Okay, so we multiply our numbers out front. 2 times 4 is 8. Okay, but we also do our square root of 2 times the square root of 2, which would be the square root of 4. Okay, well that's not simplified because what is the square root of 4? 2. So this would be the same as 8 times 2. 8 times 2 is 16. So that can be replaced with 16. Okay, and if you look, we can simplify like terms. So we have a 20 plus a 16 would be 36. 16 root 2 plus 10 root 2 would be 16 plus 10 is 26 root 2. So this would be your simplified answer, okay? You may need to practice with this. Another thing, if we have root 2 times root 2, okay, your square roots kind of cancel out. So all you're left with is the number underneath, okay? So if we have root 50 times root 50, okay, which can be simplified, but ignore that part. Root 50 times root 50 is equal to 50, okay? So that's kind of a little shortcut, little trick that you guys can use. Okay, let's do another one. Okay, so what's the product? 5 minus root 7 times 5 plus root 7. Okay, so 5 times 5 would be, 5 times 5 is right here, sorry. 5 times 5. Okay, and then 5 times 5 root 7. Negative root 7 times 5. And then negative root 7 times positive root 7, okay? So 5 times 5 is 25. And then 5 root 7, then negative 5 root 7, those cancel. Okay, and then root 7 times root 7 cancels to be root 7, or just 7. Okay, so then 25 minus 7 is equal to 18. Okay, let's do another one. I don't really like how they did their work. So let me show you like how we will do it, okay? So we multiply 6 times 6, which is 36. Okay, we multiply 6 times root 12, which is positive 6 square roots of 12. Okay, now we do our negative root 12 times 6, so that would be a negative 6 root 12. And lastly, we do our root 12 times, so our negative root 12 times a positive root 12 would be a negative. Root 12 times root 12, roots cancel, so we just have a positive 12. Okay, now we can simplify our like terms. Okay, so 36 minus 12 is 24. Cancel, cancel. And then positive 6 root 12 and minus 6 root 12, those also cancel. So 24 is just our answer. Okay, and I think that's it. Okay, so MathXL, you have 8 total questions. And let us know if you have any questions or if you need help simplifying radicals or anything like that.